Hi guys, Miss Carl here. I thought I'd just take you through page 67 because I had a couple of people emailing me saying they weren't quite sure how to do it. So, page 67 is looking at precipitation reactions, which are the ones where we put two solutions or two liquids together and they form a solid and a liquid together. Kind of like when we did our lead nitrate experiment where it turned yellow solid with some clear liquid. So, on page 67, the first question, question A, is sodium and hydrochloric acid. So how do you work this one out? Well, there's a few steps we have to go through. The first one we want to figure out is what's actually in my reactants. So, what's in our reactants? Sodium is nice and easy, it's just sodium, just the metal by itself. Hydrochloric acid, that one's a little bit harder to figure out just because you have to read the name a little bit, but hydro as in hydrogen and chloric as in chlorine. Right? So sodium plus hydrochloric acid, these are our parts. The second step is we have to figure out what goes with what. We have to figure out, is it positive, is it negative, and what can match up. Because we know our positives can't go with positives, negatives can't go with negatives. So sodium we know is a plus, and if you're not sure you can look at your table on page 22. Hydrogen, also a plus, and chlorine, that's a minus. So we've got sodium is plus, hydrogen's plus, chlorine's minus. So we have to figure out, well, what can go with what? We know that if they're reacting, these two can't stick together as much as they'd like to. So when we react them together, we know they have to change. Hydrogen can't go with sodium because they're two pluses. So sodium must go with chlorine. So sodium goes with chlorine, and so sodium chloride. And hydrogen, it's all left by itself. Okay, so that's step number 2 done. We've figured out that those two can go together. That one's now all by itself. Step number 3, we have to look at, is there a rule about these different pairings? So by rules, I mean on page 66, there's this table here, all about solubility rules. And I can't see any rules about hydrogen, so let's leave that for the moment. But sodium chloride is a chloride. So rule number 2. All soluble except for AgCl and PbCl. Well, it's neither one of those, so it has to be soluble. And soluble means can dissolve. So, sodium chloride, soluble. And if we were going to write it in the equation, we could put a little AQ next to it because it's aqueous, able to dissolve. Hydrogen, that's a gas, it doesn't actually dissolve back in, but we don't need to know that. So that's question A sorted. Our ionic product, the thing that's a positive and a negative together, is sodium chloride, and the solubility is soluble. Let's try another one. Now, I don't want to try B, I think I'll leave that one to you guys, but let's try letter E altogether. So this is E, is barium chloride, going with sodium hydroxide. So, again, we go through all those steps. Step 1, what is in my reactants? This one's nice and easy because it's just what it says it is. There's barium, there's chloride, there's sodium, and there's hydroxide. Easy. Just leave it as it is. Step 2, what goes with what? Barium is a positive, like it says on the chart in 22. Chloride, we all know that one's negative. Sodium, again, positive. And hydroxide, negative. Now, when we're working out what can go with what here, it's not trickier, but we have to keep in mind that these two can't stick together. Because these are reacting, we know that there's a bit of a muddle up. So, what can barium go with? Barium can't stay with chloride. It's got to be a reaction. Barium can't go with sodium because sodium is a positive and barium's a positive. but barium can go with hydroxide. So we end up with, oops, there's my arrow, barium hydroxide, which leaves two things. We've got sodium and we've got chloride. Can they go together? Yes, they can. Sodium, oops, almost wrote hydroxide again, sodium chloride. Okay, step number 3, is there a rule? In this case there's 2 gaps, so we know that there's going to be 2 rules. So let's look at the barium hydroxide first. And hydroxides are all insoluble except for KOH and NaOH. Barium's Ba, so it's neither of those ones. So we know that barium must follow this rule of all of them being insoluble. What about sodium chloride, or salt as you guys know it? Let's look at the table. Yes, there's a rule. Chlorides, all soluble except for AgCl and PbCl. Sodium chloride, it's not one of those, we know it's NaCl, and so it must be soluble. It can dissolve in water, which we know because it's salt water. So that's how to do it, guys. Don't forget these steps. Just take yourself through it nice and slowly. Step 1, figure out what's actually in your reaction, reactants. Sorry. Step 2, which ones are the positives, which ones are the negatives, so what goes with what. Step 3, is there a rule about it on page 66? And step 4, what's the solubility? Can it dissolve? Alright, good luck guys. Email me any questions you've got. Bye.